Okay, let's move on. Let's talk about the multiplication rule for independent events. And these are about and events. When we looked at the addition rule, that was for, the probability of E or F. Now we're going to talk about the probability of E and F. Okay, so if they're independent, all right, the probability of E occurring and F occurring, I can get by multiplying them together. This is the probability of E times the probability of F. In addition, if I have a bunch of events that are independent, E1, E2, En, I have N events and they're all independent of each other, then the probability that all of them occur, E1 and E2 and En, all of is you multiply all the probabilities, the probability of E1 times the probability of E2 times the probability of E3, all the way up to probability En. And if all of their probabilities happen to be the same, for instance, if I flip a coin 20 times, the probability of a head is 0.5, all right? So each time the event of getting a head is the same, that would be where P is half, then the probability of all of them is going to be P times P times P times, so I'm going to have N P's multiplied together. And when I have P times P times P, and there's N of these, then when I multiply that together, I get P to the N. So the power, the nth power means multiply it N times, okay? So it's not N times P, it's P to the N when we multiply. If I add P's, P plus P plus P, that's gonna be NP, okay? Which we don't do. All right, select a card from a regular deck of cards and we're gonna put it back in shuffle. These are independent. So I'm doing the first one. I pull out a card, it's an ace. I stick it back in, shuffle again, pull out a second card. So I got 2 cards. What is the probability that both cards are kings? All right, since they're independent, this is going to be the probability that the first one is a king times the probability that the second one is a king. And they're both the same. This is going to be, 4 over 52 times 4 over 52, which I could write that as 4 over 52 squared. But that ends up equaling 0.0059. So is that unusual? Yes, this is less than 5%. This guy, this little 0 here is less than 5. Therefore, this is unusual. So it'd be unusual to pick 2 kings in a row. All right. All right, let's flip a coin 10 times. What's the probability we get 10 heads? All right. So the probability of 10 heads, this is going to be, so this is this rule. I have 10 trials, I have 10 events. They all have probably 1/2 and they're independent. So this is going to be 1/2 to the 10th power, or 0.5 to the 10th power. However you want, they're all the same. All right, and 0.5 to the 10th power is very small, 0.00098. So that is around 10 over 1, 2, 3, 4 zeros, 9.8. It's, rounds to 10. So for every 10,000, so if I call this 0.01, so about 1 in every 1,000 times that I flip a coin 10 times, then I'll get all heads. So it can happen. It's very unlikely. It's extremely unusual. All right. So what is the probability the first 5 flips are heads and the last 5 flips are not? All right. So this is going to be the probability of 5 heads in a row and then 5 tails. Oops, not. This is and. And 5 tails. All right. So the 5 heads, they have a probability of 1/2. I'm going to have those to the 5th power. Now I got tails. Those are all have a probability of 1/2, and I'm going to have those to the 5th power. So same thing, it's 1/2 to the 10th power, which is 0.0098. Okay. So what's the probability that the first 5 flips are head? And you can think about this is the first that there's 5 heads and then there's anything for the next 5. All right, well, these are independent. So the next 5 events are not going to affect the first 5. So this is just the probability of getting 5 heads. Wrap your mind around that. So it doesn't matter what, I'm only concerned with the first 5. And this is going to be 1/2 to the 5th power, which happens to be 0.031, also unlikely to get 5 heads.